Okay, so work is a scalar. What does that mean? It can only be described with a number. That is correct. Well done. Josh is on fire today. So work is a scalar, but it does have a positive, negative character. Now, typically when we talk about positives and negatives in physics, it stands for direction. So like up is positive, down is negative, forward is positive, backward is negative. But sometimes positive and negative can mean other things, like, Trevor? Right, like is the work being absorbed? Is it being transferred? Is it being given away? Is it, that kind of thing. Correct. We also use positive and negative with acceleration, which can mean slowing down or speeding up. I kind of put them all together. Slowing down or speeding up, which is not a direction, is it? So the positive and negative character for work, for us as humans, is dependent on the use for the work. In other words, is it useful for us? So positive work, we're going to call good. So yes, we are going to have a value judgment on work. And negative work is bad. And this is really what engineers are all about. Okay? When you hear about like efficiency, there really is no such, in the scientific world, there's no such thing as good and bad. There just is science. So good and bad depends on what we want to use. Yeah, what we want to use the energy for. Go ahead, Perry.
Proper and improper science.
Proper and improper science? Okay, now you have to, I hate to ask, but now you have to expand.
Proper science, actually recording every stuff, every event of our lives and making interpretations of it. Improper science. Chemical A plus chemical B plus chemical C equals boom. Don't know how.
Okay. So doing it for fun, just science for the sake of science, right? Well, no, that actually has excellent merit. You guys know, I think we've talked about this, that serendipity, science just for the sake of discovery, oftentimes leads to something that becomes useful to humans, right? This would be technology. Good or bad use. What do we want to use it for? Energy has really no positive or negative value. So this is really us assigning it a value based on our use. Let me give you an example. If you took $10 worth of gas and put it in your car, put it in your fuel tank in your car. Some of that gas, and it depends on the car and the efficiency, some of that gas would make your car go down the road. But some of that gas will be converted into a different form of energy that will not necessarily push your car down the road, correct? What other forms besides make car go forms will the gas turn into? Somebody other than Perry, who I love, saying both. Heat energy, where? In what forms? Heating up what?
Heating up the gasoline.
Heating the gasoline itself, yep. And then what do we do with that heat?
It's wasted.
Some of it is wasted. Where does it go? Into the atmosphere. If you stand behind the car, you'll feel that heat coming out the tailpipe, right? Trevor, another form. Yep. You could turn that into, in fact, if you drove an old VW Bug, the heat from the engine was directly used to heat the interior of the car. It had some drawbacks as well, but yeah. So sometimes the heat is useful. Sometimes it's just wasted in terms of human form. So take a guess at a typical car engine. How much of that $10 gets you down the road? $7.50, $8, $3. It's about $6. Now, these numbers can fluctuate pretty drastically depending on, the type of car. So $7 or $6 go down the road. What does the other $4 turn into? Yep. So $4 turns into heat. So if we were going to assign a positive and negative value based on what we consider good energy for human purposes versus bad energy, would the 6 get a positive or a negative designation? And the 4? If the goal is, I want to go down the road. But what if the goal is, I'd like to cook breakfast on my engine? Then this would become positive energy, correct? True, so we would have to be specific. So, well, no, he's absolutely right. Tyler's right. So of that $4 worth of heat energy, where am I cooking it? Am I cooking my breakfast out the tailpipe, or am I actually cooking it on the engine block? So yes, we could even get real fussy with that. Perry.
You can actually convert all $10 worth of fuel to heat energy by putting it in plug and swap.
By putting it into park?
Yep.
Okay. So, do you see the purpose of this example? The purpose is figure out what it is, what's the goal. So if we're doing work or energy problems, a positive and negative character is dependent upon or defined by the human goal. Izzy? Well, hit me, sister.
Okay, so
We were talking about Fangbo's butt, so it's fine.
depending on the quality of the gas that you're purchasing and putting in your vehicle, would you get more mileage down the road than?
That is not irrelevant at all. So if I use premium
Yeah.
gas, yeah. The answer is yes. It will make a difference. Here's the next question. Is it cost effective? Right? So if I put premium gas, and let's say this ratio changes to $7 and $3, right? Did that extra buck, did it cost me an extra buck? Do you see what I'm getting at? If I got another $1 worth of efficiency out of my engine because of using better fuel, was it worth it? Does anybody know the answer to that? If it's under the $1, it would be worth it, yep. Because you just got $1 more energy out of that gas tank. And if it's over it out. So what do you think about premium fuel? Do you think it's worth the extra cost?
Well, it also depends on the car, because if the car requires it or whatever.
Right.
If you use normal gas, it'll wear it down, and then you can have to pay for repairs.
Right. So now it gets more complicated, doesn't it? Everybody follow Nick's? Yeah. So it's not just about getting you down the road. It's also about the cost of, the repair and maintenance on your vehicle. Perry, go ahead.
You can also change the engine. Because a while back, I was looking around. I know Michigan State had, Michigan State, they were developing an engine that had a higher efficiency than what the
Yeah, you mean you could swap out the engine and get a different ratio?
Yep.
You absolutely could.